this lesson, we'll be solving the intersection of trigonometric functions. So we're given the graph of g of x is equal to cosine x, as well as f of x is equal to sine x. So we want to know what is this point where the two graphs intersect. So you can see they intersect here and here. Of course, these graphs will continue to intersect anywhere else, because remember we said that the sine graph and the cosine graph, they are infinite, so they are going forever. But we have chosen this domain so that we can work with. So assuming that this is 90, this is 180, this is 270, and then 360. How can we find the values of x of which these two graphs will intersect? Well, if they're intersecting, it means at that point they have the same values. They've got the same values of x and they've got the same values of y. So if f of x has got the value of 1.5, even g of x will have a value of 1.5. If the value of y is 2, even if the value of y of g is 2, the value of f of y will also be 2. So let's see. So I want to know the point of intersection. So to intersect is to meet, right? So if they intersect, it means they've got the same values of x and y at that point. So how can we solve for the point of intersection? You always have to equate the two functions. So for them to be equal, it means that g of x must be equal to f of x. So now, what is g of x? G of x is cosine x, as you can see here. We said g of x is cosine x and f of x is sine x. So when you see g of x, you just replace cosine x, and then here on f of x, you replace that with sine x. And then now the question is, how can we solve for x here? Well, remember that tangent x, if tangent x is equal to 1, what is the angle that will give you the value of 1? Is tan of what angle that is equal to 1? It turns out that tan of 45 is equal to 1. So if we've got cosine x is equal to sine x, how can we bring tan in this case? Well, remember that tangent x okay, so remember that tangent x is equal to sine x divided by the cosine of x, right? So tan x is equal to sine x divided by cosine x. So how can we bring sine x over cosine x here? Well, if we divide both sides by cosine x, even this side, we also divide by the cosine of x. On the left side, the cosine will cancel the cosine and you're left with 1. And on the right side, you've got sine x divided by cos x, which is equal to tan x. So we can say that cos x and cos x, they cancel and you're left with 1. And on the right side, you've got sine x divided by the cosine of x, which is equal to tan x. And we just said that the angle of 45 that will make 1, right? So if tan x is equal to 1, then how can we solve for x? Well, you can move the tan to the other side, becomes arctan, right? So x is equal to the arctan of 1. And if you press that on your calculator, it must give you 45 degrees. So it means that the point where the two graphs intersect will be at 45, right? So this value will be here. So let's zoom in this graph. Okay. So that point is going to be here at 45, right? If you can see, 45 is halfway between 0 and 90. So the first value of x where they intersect is at 45. So let's clear some space and see how can we get the second value, because we can see from the graph that they intersect at 2 points, right? So now the graph of sine and cos are symmetrical, right? So this point here is the maximum, as we've said in the previous lesson, and this value here, this one here, is the minimum, right? So this one here is the minimum. So the distance from this intersection to the maximum is the same as the distance from this intersection to the minimum, because the graphs are symmetrical, right? Meaning they're identical on above and below, they're identical. So if this point here is 45 and this one is 90, well, to move from the intersection to the maximum, we've moved a distance of 45. This means that even here, to get the intersection here, we're gonna have to move from the minimum 45 degrees from the minimum, right? So if this point is 270, we're just gonna move 45 degrees to the left, right? So then we get 270 minus 45, right? So that will be the second point of intersection where the two graphs meet, okay? And then what do you get? You get 225. So just to repeat, from this intersection to the maximum, we have moved 45 degrees. To move from 45 to 90, you have to move 45 degrees to the right, right? But then now that we are here, we are below the graph, we are now looking at the second intersection. Even to move from this intersection to this one, you must also move 45 degrees due to the symmetry of the graphs, right? So if I moved from the first intersection to the maximum 45 degrees, I must also move from the second intersection to the minimum by 45 degrees. So since we know that the minimum is at the value of x of 270, for us to know the value of x on the second intersection, which is here, I simply have to subtract 45 from 270, and then I get 225. So it means that the graphs meet at these 2 points, as you can see. The first point is at 45, and the second point is at 225. Okay, so these are the values of x where the two graphs intersect. So how can we find the values of y, where that corresponds to these x values? So remember, they are going to have the same value of y, right? So we can solve the value of y for only one, and then the value of x, this x1, and then is x2. Okay, so now how can we do that? So since the two graphs, the graph of g of x and the graph of f of x, are equal at this point, it doesn't matter where I replace x into. So I can replace x into g, or I can replace x into f. I will still get the same answer. So now let's use this value of x and plug it into g of x. So if we do that, we're going to have cosine of 45, and the cosine of 45 is equal to the square root of 2 over 2, right? And then that will be the value of y where the two graphs intersect, because this is the value of x and this is the g of x. Remember, g of x can also be written as y. So g of x and y, they simply represents one thing, it's a function. So it means that the value of y where that corresponds to 45, it's square root of 2 over 2. Just so that you are assured, let's also plug in the value of x2 into now let's use f of x, and we must get the same answer. So f of 225 is going to be equal to the sine of 225. Okay, but then now, because it is below the graph, we expect to have a negative answer, right, for the value of y. So the sine of 225 is negative square root of 2 over 2, just as we expected it. So it means that the first intersection, which is let's call it intersection A, and let's call this one intersection B. So the first intersection has got the value of x of 45 and the value of y of square root of 2 over 2. And the second intersection, which is B, has got the value of x of 225 and its value of y is the same as the value of y of a, but with a negative sign. That is the negative square root of 2 over 2. And these 2 points are the points where the two graphs intersect. So I hope that makes sense. So there are some questions again which you need to be familiar with, and I'm going to redraw these graphs. So we had a sine function and a cosine function. So this was 90, 180, 270, and 360. And this was 1 and minus 1. So the graph of sine was like this. And the graph of cosine was like this. If I remember, not quite sure, let's just say this is g of x is equal to cos x, and f of x is equal to sin x. So this is 1, this is minus 1, and this is 90, this is 180, this is 270, and this is 360. So we want to know for which values of x is the graph of g of x multiplied by the graph of f of x equal to 0. Where is the point that when we multiply the two functions, we get 0? So now, if a multiplied by b is equal to 0, it means that either a is equal to 0 or b equal to 0. It doesn't have to be both. If one of them is equal to 0, then the product will be 0. So if g of x multiplied by f of x is equal to 0, then it means that either g of x is equal to 0 or f of x is equal to 0. Now we're going to look for the point where the graph is 0. So remember, the line that corresponds to 0 is this one. So the graph will have the value of y of 0 as long as the point lies on this green line. So we're going to check what are the values of x that lie on this green line. Well, it's here. That's the first one on the origin. The second one is here. The third one is here. Another one is here. And the other one is here. So as long as x is all these values here, we will always get the product of g and f being 0. So it means we don't have one solution, but we've got a family of solution. So we can see that x is an element of, then we can insert all these numbers. It's 0, 90, 180, 270, and 360. So as long as the value of x is 90, 180, 270, 360, you will always have the product of f, and g being equal to 0. So at your own time you can try it, but we can try that with only one graph. So we know that cosine of 270 is equal to 0, right? But then the sine of 270 is equal to minus 1. So you can see that 0 multiplied by minus 1 is equal to 0. So as long as the value of x is somewhere between this point, 0, 90, 180, 270, or 360, the product will always evaluate to 0. So now the second one. For which values of x will f of x multiplied by g of x be a positive number? By positive we mean more than 0, right? So where is that point, or where are those points whereby when we multiply the first function g of x by the second function f of x, we get positive answers? So this is how I usually answer these problems. So as long as a graph is above the x-axis, you're gonna put positive signs on that graph. So just put positive. So this one is gonna be negative because it is below, right? So you put negatives on this graph. Then now you put positives because it is now above the x-axis. Now you do the same thing with the second graph. It's going to be positive as long as the graph it is above the x-axis, and it's gonna be negative if it is below. So what are those values of x that when we multiply g and f we get positive? So we can get positive in two cases. If we are multiplying a positive times a positive, or we're multiplying a negative times a negative. So let's look for a place where we've got positive times positive or negative times negative. So if you can check, I'm gonna draw a line here. Let me use a different color for that. So I'm gonna draw a line here on 90 and another line on 180 and then another one at 360, right? Let's draw another one here. So now in the first interval between 0 and 90, we've got positive times positive, right? So this is the interval which we're looking for. So in this interval, we've got positive times positive. We just multiplied the first graph by the second graph. So it's positive times positive, 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 right? Okay. They said more than 0, right? So we're looking for positive here. Okay. On the second interval between 90 and 180, we've got positive times negative, right? And this is not what we are looking for. So it means that in this interval, we are going to skip it. It's not what we are looking for, because in this interval, we've got positive multiplied by negative. Now we move to the third interval between 180 and 270. We have got a negative times a negative, and it is what we are looking for, right? Then you go to the fourth interval between 270 and 360. We've got positive multiplied by negative, and this is not what we're looking for. So here we've got positive multiplied by negative. So the only two intervals which gives us the condition which we're looking for is between 0 and 90, as well as between 180 and 270. So your answer is going to be in this form. So we're going to say that we get positive times positive when x lies between, right? And it also includes, but then here we don't include because they didn't tell us to include it. They just said more than 0, right? So it means that as long as we are between 0 and 90, then we're going to have g of x multiplied by f of x being equal to 0. If the question came like this, if this more than sign or greater than sign had got equal to, then we're gonna put it even on the solution. But because they didn't specify, you also don't have to put it on your answer. So as long as we are between 0 and 90, the two graphs multiplied by each other will always be positive. I'm sorry for that. Okay. And then on the second interval, we said we don't want it between 90 and 180. We're not looking for that interval. So the other interval that gives us the condition which we are looking for is if x is between 180 and 270. So remember the rule for writing these things. The smallest one must always appear on the left side of the logical operators, and then the bigger one must be on the right. Okay, so the last one, where is it that when we multiply g of x and f of x will get less than 0, meaning we'll get negative, right? And let's just say less or equal to. Okay, so now let's see. Now the conditions have increased, right? They're saying the points rather, that when we multiply the two functions, we're going to get less than 0, or we're going to have equal to 0, because this thing means less or equal to, right? So let's start with the first condition, which is less than 0, right? So less than 0 means negative. So which points is it that we multiply two functions, we get negative? So there are two conditions to get a negative when multiplying two numbers. Either you're multiplying a positive by a negative or a negative by a positive. So it's one thing, right? So what are the intervals which we said they've got a positive multiplied by a negative? Well, between this interval, between 90 and 180, right? We see that. So we can say that x, if one write it in this form. So here we can see that if x is between 90 and 180, right? Then we get positive times negative, right? And we're also including this because when x is 90, the product is 0, because here they said less or equal to, so you must be consistent with that thing, right? So you must always say less or equal to. And then the other interval where we get that is between 270 and 360. Okay, it's between 270 and 360. Then we're gonna say or x is between 270 and 360, right? And then yeah, you must be fine. So the other conditions where we said equal to 0, we did them in the first example, and then that's where you'll get it. So g of x multiplied by f of x will be equal to 0 if x is a number 0, 90, 180, 270, or 360, and this will give you f times g being equal to 0. So this is how you can answer this type of problems, and thank you for watching.